Hi AP Stats. Today we're going to take a look at lesson 9.1 day 3. And our goal today is to interpret the power of a significance test and describe what factors affect the power. So we're going to go back to the example from the beginning of this unit where I claim to be an 80% free throw shooter. Mr. G is skeptical and believes that I shoot less than 80%. So I decide to take another simple random sample of free throws to prove myself. So go ahead and write the appropriate hypotheses for the significance test. At this point, you should be pretty good with writing your hypotheses. So our null hypotheses is our claim, and my claim is that I am an 80% free throw shooter. The alternative hypotheses is that I really shoot less than 80%. And we need to define our parameter. So P is the true proportion of free throws Mrs. C makes. Okay, so now we're going to go ahead and describe a type 2 error in this setting. You should know what a type 2 error is. That's where the alternative hypothesis is true, but we fail to reject the null. So in this case, if the alternative hypothesis is true, that means Mrs. C is a less than 80% free throw shooter. But we decide that she really does shoot at 80%. Okay, so let's take a look at question number 3. So suppose that Mrs. Kell's true free throw percentage is actually 60% or 66%, that our alternative hypothesis is true. I have this information entered on the applet, and it says display the type 2 error, and it's going to show it's a blue shaded region. And if your alternative hypothesis is true, what's the probability of the type 2 error occurring, that you're going to accept or fail to reject, I should say, the null hypothesis. So let's go look. All right, so let's take a look at this applet here. Okay, so let's go ahead and take a look at this app. I have all the information already entered into the left over here, that our null hypothesis is 80, alternative is left, and we're going to display the type 2 error, where our true value of P is 0.66. So we see the two distributions. The blue curve is with our true value of P being 0.66 at the center. Our red distribution is our null hypothesis in the center of 80%. So our type 2 error said it occurs here in blue. See, if I take it off, it disappears. So there's our type 2 error. And if we look up at the top, it tells us that the probability of type 2 error is 24%. Okay, so we're going to go back and enter that information. It's going to be 0.24. So that's the probability of a bad decision of type 2 error when HA is true. Now, if HA is true, what would be the probability of a good decision? Well, it would be its complement. So if we subtract 0.24 from 1, we're going to have 0.76. Now, I put the picture down here below. Okay, so we see that here was our type 2. And they told us that it occurred 24% of the time. So the probability that we're going to make a good decision was 76%. And if we take a look here, we see 76% is our power. So I'm going to go ahead and shade that in under my curve here. What I have shaded in is your power. Okay, so what we're going to learn today is that power is going to be the probability that we make a good decision. We're going to reject the null hypothesis given that our alternative hypothesis is true. All right, so again, part B right here, this is the power. And if we think about it in terms of probability, it's the probability that we reject our null hypothesis given HA is true. Okay. All right, so interpret the probability of this good decision in the context of the problem. So if we're going to go through and interpret it, so our given is that the alternative hypothesis is true. So our alternative hypothesis would be that I am a 66% free throw shooter. When we talk about power, you have to have a specific alternative value. So if Mrs. C is a 66% free throw shooter, then there is a 76% probability that we decide correctly that she was exaggerating, meaning we decide that I really don't shoot 80%. Okay, so again, deciding correctly means you are rejecting the null hypothesis. Okay, so I just want to go ahead and take a look at this picture down below. Now again, power can be a little bit of a tricky concept. And again, in order to deal with power, you have to have a specific alternative value. And if we look down here, our specific alternative value for P was 66%. And I'm going to draw in as best I can over this line, okay? And what this line is right here, this is the cutoff to reject our null hypothesis. So if this is the cutoff where we're going to reject our null hypothesis, that means everything to the left here, I would actually reject the null hypothesis. So if I reject the null hypothesis, and I shouldn't, that's going to be a type 1 error, and we would see that this little piece right here is where your type 1 error is going to occur. Okay, so now we're going to take a look and see how changing the sample size, alpha level, and alternative p-value can affect our power. So right now we know that our power is at 76%, and we can see that shaded in green. So let's go ahead and change our sample size. Currently our sample size is 50. So I'm going to go over to the left and let's increase it to 100. Or even 116. And what happened to our power? Well, we can see our graphs got skinnier, meaning that there's less variation. And we see that our power actually increased. Okay, so increasing the sample size will increase the power, and that decreases the variability, which will decrease where the two graphs overlap. Okay, so that's the first thing we'll go ahead and we're going to add that back in. We're going to say to increase the power, we're going to increase our sample size. Okay, let's go back and take a look again. How about our alpha level? So I'm going to go back to a sample size of 50. And our alpha level. Right now we're at a 5% type 1 error, where our null hypothesis is true, but we reject it. So let's increase it to 10%. what happens to our power? Well, if we take a look here, we were originally at 76% for our power. Now if we look at the top, this is 84%. So what we're going to say here is that to increase the power, we're going to increase our significance level. And the reason that happens is because when you increase your significance level, you make rejecting the null hypothesis easier. Right? And in order, our power is when we make the good decision, when we need to reject our null hypothesis. Now, an alternative p, okay? Right now, our p-value was at 0.66, okay? So we have a p-value from 0.66 here, that's that we chose from the original null is 0.8. Now, what happens is I go ahead and I decrease that p-value. So let's take a look at an alternative p-value. Currently, our p-value is 0.66, and we see our power is at 76%. Now, what happens when I take the p-value and I increase it? I bring it closer to the 0.8. What happens? We see that our power actually decreased to 0. Okay, so increasing it made the power get smaller, but let's take a look at what happens when we decrease it. I decreased it so far that the power is now 100%. So what happens is, as we take our p-value and we make it further, become smaller and further away from our null value, we're going to see that the power is going to increase because we're decreasing the distance from the null and the alternative hypothesis. Okay, so how we're going to write that is the alternative p-value is to increase power, we're going to lower our p, but ultimately we're going to think of it like this. To increase our power, we want to increase the distance of the alternative hypothesis from our null hypothesis. Okay, so a lot of concepts here, but basically for the AP test, you're going to have to know how to find power if I give you the probability of a type 2 error. And then you're also going to have to know how to interpret power in context. Okay, so here are our important ideas. Same thing that we had before. We had our box with our errors. We had where our null hypothesis is true. The alternative hypothesis is true. Now remember, if we think that the alternative hypothesis is true, that means our null is not true. That means the same thing. Okay, we can either reject the null hypothesis or we can fail to reject. So, if our null hypothesis is true and we reject the null hypothesis, that's going to be our type 1 error. If our alternative hypothesis is true and we reject the null hypothesis, that's correct, and that probability will be our power. If our null hypothesis is true and we fail to reject the null hypothesis, that's correct, that's what we want to do. But if our alternative hypothesis is true and we fail to reject our null hypothesis, that is our type 2 error. Okay, we learned in the previous lesson that the probability of a type 1 error is equal to alpha. And the probability, and let's write that a little bit better. probability of our type 1 error we know is equal to our significance level. The probability of our type 2 error is equal to 1 minus the power. Okay, now again, we remember that power is the probability where we reject the null hypothesis given the HA, your alternative hypothesis, is true. We think of it as the probability of getting it right. So you will, if you have a question like this on the AP test, you'll have to interpret power in context. So we would say if the alternative hypothesis is true, and you must say at a specific value, in context. There is a blank percent, that's whatever your power is, a blank percent probability of finding convincing evidence to reject the null. And you always must state it in context. Okay, so we're going to talk about the other things that you need to know for understanding power is you need to know what affects it. So to increase the power, you will increase your sample size, n. To increase the power, you'll increase your significance level. To increase the power, you increase the distance to the alternative value. Okay. All right, so let's just take a look at the check understanding and see how all of this will apply. Can a 6-month exercise program increase the total body bone mineral content of a young woman? A team of researchers is planning a study to examine this question. The researchers would like to perform a test of our null hypothesis where the mean is equal to 0. And then the alternative is where the mean is greater than 0, where mu is the true mean percent change in TBBMC during the exercise program. The power of the test to detect a mean increase of TBBMC of 1% using an alpha of 0.05 and n equals 25 subjects is 0.80. Interpret this value. So to interpret a power, we have to use the alternative hypothesis at a specific value. And in this case, we know it said the alternative hypothesis said the true mean needs to be greater than 0. But now we're going to look at an increase of 1%. So that's going to be our specific value. So we're going to say if the true mean increase in TBBMC is 1%, and we'll continue to follow that template from above. There is an 80% probability that we find convincing evidence to reject the null that the mean increase in TBBMC is 0%. Now again, you're going to want to learn this template here for how to interpret your power. You're going to want to learn that. Okay, so for question number 2, find the probability of a type 1 error and the probability of a type 2 error for the test in question 1. Well, we know that the probability of a type 1 is our significance level, and if we go back, that's 0.05 from what they told us above. To find the probability of type 2, that is equal to 1 minus the power, so that's 1 minus 0.80, so we have a 20% chance of having a type 2 error. And then for question number 3, determine whether each of the following changes would increase or decrease the power of a test. So I use an alpha of 0.01 instead of using 0.05. We know that it would decrease the power if we decrease our alpha. Remember, if we make the significance level smaller, it makes it harder to reject the null hypothesis. A smaller significance level makes it harder to reject. What happens when we use n equals 100, or sample size of 100, instead of n equals 25? Well, when you use a larger sample size, you're going to have less variability. It's going to increase the power. A larger sample size increases power. Okay, so for this lesson, make sure that you go back, understand definition of power, know how to interpret it, and make sure you know how sample size, alpha, and the distance of your null value of your alternative value to your null, how it's going to affect your power. Okay, have a good night.